All right, we're going to get started in about another minute. I see a lot more people have shown up, and I asked a couple questions before we got started. So how many of you have worked with CML already? It's a good number of people. How many of you have looked at CML, but you're kind of looking to get some experience with how to use the software and maybe learn more about it? So the rest of the room. All right, and so for your use cases, before we get started, how many data center people in here? Okay. Enterprise networking. Okay, so I think you're gonna really appreciate the demos and things that we designed today because it's using enterprise gear, but we built a data center, so it's a little bit for everybody. Any service provider. Anyone for IPv6. So we got a couple people. So we're gonna get started. Good afternoon. I hope everybody's having a great week at Cisco Live. I hope you're all taking in all the learning opportunities. I asked already how many of you had worked with Cisco Modeling Labs, so I'm curious, how many of you is this your first Cisco Live? It's a good number of people. So my first Cisco Live was back in 2006, and it was an amazing week of learning, and I usually would go home and take all the things I learned and try to put it in my production network, because Cisco Modeling Labs was not a thing. I don't even think we had a good network virtualization product at that point. There was some stuff upcoming. But honestly, like you'd go, you learn all these things, and you get home and you maybe don't get to implement it. So Cisco Modeling Labs gives us that capability to take the things that we're gonna learn this week, data center, enterprise, service provider, IPv4, v6, all of the stuff you learned this week, you can take home and start working with. So in this session today called Model It Up, Building Networks with Cisco Modeling Labs, we're gonna take a look at how we can do that. I'm gonna run the gamut of all the different protocols, different topologies, and we're gonna look at how we can build a network with a couple different things. And so my name is Matt Luschner. I'm a solution engineer supporting the federal group. I have a lot of really diverse customers, and it's a very exciting group. And we have challenges there where I take Cisco Modeling Labs to build scenarios to work through some of their problems. And so on a day-to-day basis, I work through every major network type, data center, service provider, enterprise, and I build those labs in Cisco Modeling Labs. So before we get started, if you have not joined the WebEx space, you can bring up the Cisco Events app. You can look for the session, and then you can sign up to join the WebEx room. I have deposited the PDF slides into the room. I also have a GitHub page that has the lab, topology files, a whole bunch of documentation, all the configurations. You can take this home, and if you have CML, or you stand up a CML server, you can run this lab. It does not require a lot of resources, and we'll talk about that in a little bit. Everything that you see today was done in CML. There's only one component that was external of CML, and if you haven't seen it yet, if you're still kind of trying to decide on Cisco Modeling Labs, there is a free tier available, so you can download that, you can run 5 nodes, and start getting some hands-on with the product. So let's jump into who am I? Who is your speaker? So I'm a solutions engineer. I've been with Cisco for 6 years. I have 23 years of experience in IT. It's a diverse background. I've done networking, virtualization, I do desktop services, and I started getting into automation and coding. And Cisco Modeling Labs was the tool that became my kind of automation engine where I want to test things, I want to see how it works with the software. And I think you're all pretty lucky, because I'm probably the only speaker at Cisco Live with an unlicensed nuclear accelerator. Back home, I'm in a group called the Charm City Ghostbusters, and we do charitable events and things throughout the year, Comic-Cons, all that good stuff. And occasionally, you might see me hanging out of the side of the car asking people, who are you going to call? There we go, somebody's awake. All right, let's talk about our agenda. So we're gonna get started. And so we're gonna get started, we're gonna look at Cisco Modeling Labs, we're gonna look at the software, what it gives you, kind of what it looks like, kind of give you a taste for some of the nodes. Then we're gonna talk about scaling your resources. I frequently get questions about, what do I need to run CML? How many resources do I need? Should I focus on CPU, disk, memory? So we're gonna talk about that and kind of where you wanna put it and where you wanna direct those resources to you based on what you're trying to build. Then we're going to build a network. I'm going to walk you through the process that I use to build my networks out. And you'll kind of see why, and I'll kind of talk about why I do those things. But we'll build out a network, and it'll be the network that I have provided you in the GitHub repo. And we're going to operate networks. This is a very important part for me because building a lab in Cisco Modeling Labs is useless if you don't start testing like things with it. So services, providing DNS, just doing pings on the network doesn't tell you a lot about how the network is operating. Can you SSH? Are your firewalls working? So we'll look at how we can operate our networks. So the 3 reasons you're attending this session. So you're interested in learning about Cisco Modeling Labs. So we'll give you a little taste of what it is and what it can provide you. You want to understand those lab resources. What do I need? Where do I need to apply more memory or disk? And at what point do I need to do that? And we're going to talk about learning how to build those labs in Cisco Modeling Labs. So let's go ahead and get started. So why should you be interested in Cisco Modeling Labs? Anybody have any thoughts on why they might be interested in it? Anyone want to blurt something out? Yep, that's a really good example. And I like to make this point that it's not just for certifications, because that's a really good example. Like, you should be using Cisco Modeling Labs. You should be using some kind of modeling tool to start getting more hands-on with networkings. Because as network engineers, we don't get a lot of opportunity to do the engineering part. It starts to become break-fix at some point. We're putting out fires. If we want to learn how a migration would work, if we want to try a new topology on our network, we don't get that opportunity. So Cisco Modeling Labs kind of gives us that avenue to start doing it. We get features like packet capture. If you've never looked at a Wireshark PCAP, you can do it right in CML. We can do link conditioning, so we can put some fault on the network so we can adjust policies. If we want to know, if we take 10% link loss somewhere, how do we adjust our network accordingly? And then, obviously, the big one, planning and testing network changes. You want to do a change in your production network, test it in Cisco Modeling Labs first. So you're going to get actual control and data plane activity, so the things that you see on your hardware, you're going to see in the software. And so some of the benefits of network modeling I see as a twofold thing, and they both kind of play off each other. So the first one is rapid prototyping. You can take an idea. You want to try VXLAN. You want to try a service provider network. You build it in Cisco Modeling Labs. There is a massive cost savings over hardware. Imagine if you wanted to go build a data center network on Nexus today and then switch over to iOS XE with Catalyst tomorrow. It's not an inexpensive swap out to try a technology. Do it in CML. We can build an actual test environment. What you're seeing in the software is what you're pretty much going to see on hardware. There might be a little bit of differences between the two because hardware's got some things that software can't emulate. We can test the failure scenario. So like I said, that packet capturing, that link conditioning, we can kind of see what's going on with our network and get an understanding of the failure. Plan a migration. So you want to move your layer 2 switch fabric in your data center to VXLAN. Plan it out, see what it's going to look like, get a feel for those changes before you put it in production. But all this gives you skill development. You're going to get hands-on experience with the protocols. I've put 8 protocols and topologies and technologies into this lab that you saw today. I got a lot of hands-on experience putting this lab together so I could show you everything that we can do in CML. We do the packet analysis so we can look at those PCAPs and understand what's going on in our network. If you want to start doing automation into your network, there's a lot of talk about it. This is the way to do it. Do not do it on your production network. Model your network in CML and then put it into practice. But I always tell people, everyone's like, I want hardware. I want to work with the hardware. I want to get experience with hardware. I tell everybody that's not what you're really interested in. You're interested in the software. The hardware part is sticking into a rack, plugging in a cable, and watching a little light turn on. The software is where the magic's at. So, when you get Cisco Modeling Labs stood up for the first time, we've loaded it, you're going to get brought to this really nice dashboard. I switched it to dark mode, so you'll actually get a nice blue and white screen. I created a user, so I want to log in as Cisco Live. And you get dropped on a dashboard. Now, new out of the box, it'll be a blank dashboard. But I want you to look at some of the topologies up there. My team back in Maryland, we build networks for SD-WAN, for VXLAN, for Catalyst Center demos. One of our guys does K3's distributions with Cilium so we can test out Kubernetes in CML. And then I went out because I wanted to learn segment routing. I really wanted to understand the software, what it could do, how the protocols worked. And I wanted to build an IPv4 to IPv6 network. So how do I translate IPv4 to v6, work with segment routing v6? So I built this lab out. I've annotated it. So if somebody comes in behind you and wants to work on this network, they can see everything you've done. We can see the border gate, or BGP adjacencies. We can see the ASs we've used. We can see where our segment routing domain is. We can see where our IPsec tunnel's been set up and where the loopbacks are. And you get a wide variety of nodes to work with. This is what comes out of the box. We get firewalls. We get iOS XE. We get Nexus. We get iOS XR. You can do both ASA and Firepower Threat Defense. We even get access to managers like SD-WAN and Firepower Management Center. But you're not limited to those nodes. CML, the team has put together a nice GitHub repository. There's a community page where you can download third-party node definitions. All you need to do is provide the QCal. So if another vendor has a QCal that you can use, download it, upload the software to CML, and grab the node definition. So let's talk about resources. And you don't need to run CML on a massive server to learn networking. How many people think you need a massive server to run networking? Or do CML? Anyone? No? You all think you can get on something small? Well, you're right. The lab that I built today, I put on this NUC. 8 cores, 16 gig of RAM. There's 27 nodes running on here. And like I mentioned, I'm demonstrating 8 different network topologies, protocols, a whole lot of stuff. I've said this on more than one occasion. And so you saw the lab. You can see it here. This is what's running our lab. This CML server has a couple different external connectors on it. But what's most interesting to me is the Ubuntu. That Ubuntu host connects to the switch, and then it feeds back into CML. And the network you see today, in order for that other NUC to get out, it has to traverse the CML network to reach the internet. So if I wanted to know what that NUC was doing, if I wanted to do some things with it, I can monitor the entire path of my network through CML and watch the activity of that system. So how do we scope the size of our server? It's going to come down to 3 things: node type and count. And I would argue the first two kind of play off each other. If you use small nodes, you can do a lot with a little. If you say, I want to run Catalyst 9K or iOS XR 9000V, you're going to need a lot more resources. And if you want to scale that out, if you want to do a lot of those node types, that's going to kind of play on what resources you need. And then finally, the use of managers. Both SD-WAN and the Firepower Management Center use 32 gig of RAM out of the box. So right out of the gate, you need a pretty good server to run it. But for learning networking, for learning the things that we're going to see today, we don't need the manager. We can get experience with the protocols on a pretty lightweight system. And so when you're considering the resources, let's talk about where those resources kind of come into play. CPU, which we'll see in a little bit, spikes at the launch. So you'll see a quick uptick. CPU might go to 50%, and it'll come back down. Disk. Disk is going to kind of grow as you add nodes. So if you put big nodes on there, like the 9000V, some of the servers, those will kind of build out your disk space. As you put labs on there, so you run more labs, or you build different scenarios, that's going to consume disk space. If you do physical hardware, like you do bare metal, you're going to want to try to supply as much disk as you can, because it's going to be really hard to add after the fact. If you do it virtually, you use the OVA, you can just add more space, extend out the drive, and fix your space problem. But memory's the big one, and we'll see that in just a few minutes. If you use feature nodes, and what do I call a feature node? It's going to be the 9Ks, it's going to be the Catalyst 8K, the XR 9KV, and both those controllers. Those are very high memory utilization systems. So if you use a lot of those, if you decide you want to build a big lab, you're going to want to have corresponding resources. And so when we look at this kind of heat map of where the resource utilization is, we've got the lighter weight systems up here. We've got the Alpine Linux, which is a really great host to stick on a network, do SSH ping. You can add some extra services to it if you want. The IOL, the iOS on Linux, router and switch. You're going to see in a few minutes how feature-packed these are, but they're super lightweight because they don't run as a full VM. And then the iOS and iOS VL2. Now these are the older legacy-style iOS. From a CPU perspective, they're a little heavier. But as we move up the spectrum, you can see that the node types start to consume more memory. So if you wanted to have the full-featured iOS XE router with that Catalyst 8000V, you're looking at 4 gig. So every node you put on there, you want to account for about 4 gig of RAM. With the SD-WAN validator and controller, same thing, they're about 4 gig. The ASA is pretty lightweight, and we're going to use that in the lab today because with the resources and the way I was able to build out the lab, I was able to get firewall services in and still use an actual feature node type. Then we get to the far end. So you decide, I want to build a data center fabric with VXLAN using Nexus. You're going to want about 8 to 10 gig of memory per node. So now you can see it's going to scale out quite a bit. And at the end, the beasts. The 9000V for Catalyst uses 16 or 18 gig of RAM out of the box. But it's emulating the control plane, so it's a little more CPU heavy. So the ASICs, the Q200 and the UATP ASIC are emulated in the software. So you get a little more realistic functionality of what they do in production. And then again, the controllers. So from a hardware recommendation standpoint, like what would I recommend you to use for hardware? For learning, you can absolutely get away with something like this. I built a large topology. If you want to learn anything about networking, you can get it running with something like this. A very small VM, your desktop PC. And we're talking about something that's got 4-core x86 processor, 8 to 16 gig of RAM, and you're probably, again, you're going to be looking at those IOL and IOL L2 images. If you want to start working with the Nexus 9K, the Catalyst 8K, you're going to move into this medium topology. You're probably looking at 32 to 64 gig of RAM, probably a 12-core processor, and then you're going to get that mix of node types. Then we've got the feature-rich topology. Now we're talking about running controllers in the lab. We want to run FMC. We want to run an FTD image, maybe SD-WAN. You're going to want at least a 24-core processor to be able to build out the scale. If you want to do a small-scale network, you might be able to get away with the medium topology. But for a controller, you're going to burn half your memory right out of the gate. You might be talking about clustered hardware. If you want to have multiple people running simulations, building out their labs, you might want to cluster out the hardware just to expand out how many servers you have, how much compute. The node that I showed you at the beginning that my team is using, that is a 6-node cluster, and that's how we're able to run all of those different labs. So if you have limited resources, how can you do more? And we're going to take a look at trying to run 20 of the Cat 8000Vs. And like I mentioned, they're 1 CPU, 4 gig of RAM. If we run it, we don't have enough resources to put all of these nodes on this little NUC I have. So I start up 4 nodes. And you can see CPU is spiked. Memory is red, like right out of the gate. We've allocated more RAM than available. So I'm at 16 gig on a 15 gig roughly system. Not long after I got this running, node 1 crashed. It just died. Probably got starved for resources. One of the nodes is up, 2 of them are running. But look at the CPU. CPU has dropped back down to 10%. So again, from a CPU utilization standpoint, it's really that first startup of getting them running. But the memory has kind of stuck. It's only come down a little bit. And now we're getting a warning that the system is experiencing high load. It's got a lot of memory on it. I need to wait until things clear up to bring up some nodes. So if we dig into one of the nodes and we look at what the utilization looks like, we can see we're using 64% of the RAM. But the actual committed memory is at 91%. You do the math, it's about 11 gig that the Catalyst 8000Vs are using to run the system. The memory has not dropped. CPU is idling at about 8%. we got a ton of insufficient hardware resource warnings popping up. And basically, the point here is that you're not going to be able to oversubscribe CML with the VMs. The memory is kind of the sticking point, in my opinion. If you decide you're going to run a lot of 8 gig or 4 gig node types, you're going to want the resources according. So how can we optimize that design? I put in 28,000 V routers. They were never going to launch. But if we use the iOS on Linux, which I have found to be a very feature-packed node type, you get a lot of capability in the software and a much significant resource usage versus the 8,000 V and the 9,000 V. They're still running iOS XE. It's stripped down, so you're not going to get RESTconf. They're not going to do SD-WAN. But most of the features and functionality that we want to be able to do are still there. They've got the similar data plane and control plane functions. For the router, you can get all your basic routing protocols. You can do V4, V6 for IP. We can build tunnels. You can do segment routing, SRv6. You're going to get some service provider stuff. You can do all of this on that super lightweight node. On the switch, you're going to get access to all the typical switch things. It's an L2 switch with L3 capability, so we can do SVIs. We can do switch ports, trunks, pretty much the usual things you would expect to be able to do on a switch. The one that I found to be most exciting was VXLAN. Did not expect to be able to do that, and that's what I put into the lab today. So let's now try that same scenario, all 20 nodes. Let's try to fire them all up. So we're going to do the 20 nodes that are 1 vCPU, 1 gig of RAM each, same system at 8 gigs, 8 CPUs and 16 gig of RAM. It's going to oversubscribe CML by 4 gigabyte. So when this is done, there will be 20 gig of memory in use. So we start 9 nodes. A couple of them are already up and running. Before I could even take this picture, they were almost all up. CPU barely changed. It's at 1.48%, just a tick. Memory's only gone up to 2.38 gig. All the routers are running now. So in a span, I'll tell you, this is about 30 to 45 seconds. All these nodes are up and running. They have management IPs on them. Like I've got very basic config on them. They are doing some stuff. But I'm at I'm less than 1% CPU. 4.4 gig of RAM. 20 nodes, I'm using all my licenses now. I've allocated 20 gig of RAM to the system. So these node types, super lightweight. They don't hit your resource budget too hard, so you can do a lot with little. And if we go back and do a boot comparison of those two nodes, the 8000V, we can see at peak, 50% CPU utilization, 87% memory. But with the 20 IOL nodes, giving us roughly the same capability, much less resource utilization. If we were to take a couple of those out, we could probably throw some firewalls in there. Might be able to throw a Catalyst 8000V router in there because they're so lightweight. Those node types will still work with the other node types. They'll still communicate with a firewall. They'll still communicate with a Nexus. They're just super lightweight. And so from a learning perspective, this is a great way to get hands-on with a lot of different topologies, a lot of different technologies in CML. So let's talk about building networks. That's why we're here. We want to talk about building a network. And I get this question a lot. Where do I start with this blank canvas? I just bought CML. I don't know what to do with it. We could build a network. And people are like, well, I don't know what kind of network I want to build. What do you want to build? What do you want to learn today? So let's talk about some ideas to populate your canvas. Let's tie it back to what we talked about at the beginning, rapid prototyping. If you want to test your network configurations from your production network, do it in CML. If you want to test the network migration, if you want to see what would happen if you changed just 1 or 2 little things in your configuration as it exists today before you do it in production, do it in CML. What if you want to experiment with changes to your network? What if you want to be the rock and roll star that's doing automation? Put your production network in there and start doing Ansible, Terraform, all of those things. They will work with the software. But you're going to gain valuable protocol experience. I did not know that much about IPv6 before the start of the year. I have dove into it. I probably am not an expert on it, but I'm comfortable with it. I can have conversations with people about IPv6, the value, and how to work with it. At this point, I'm as good with it as I was IPv4 subnetting. It's just kind of becoming second nature now. You can work with BGP. A lot of us probably don't get experience working with that protocol, so there's an option here where you can build out some networks and start getting experience with it. I love VXLAN. I work with it all the time, and I found it a great way to learn how to do VXLAN for both NXOS and iOS XE. But let's not rule out skill development. It is a great way to get your CCNA, NP, or IE and start building out labs to get comfort with it. And if we look at some of the sample topologies we can build in CML, VLANs, switching, routing protocols, pretty much table stakes. But you're not limited to that. And this, again, this is a sample of what you can do. It's IPv6. If you have a Catalyst Center, you can spin up the Cat 9000 vNodes, attach them to Catalyst Center. You can build an SDA fabric. Firewalls, ACLs. If you want to see what would happen with a firewall change, throw it in there. It is a functional firewall. It will block traffic. It will inspect it. It will drop packets. All right, so let's build. Let's talk about the procedures and kind of the process I go through when I build my own networks. And out of the gate, I always start my networks off with an external connector in bridge mode. I do that so that I have access from my home network, from my office network into CML. And the reason I do that, how many of you go running around your data center with a console cable to do configurations? Nobody. We SSH to our boxes. We get on a jump host, we maybe do it from our desktop, but we have something that we go to do our management of our devices. I set up a Ubuntu host because I'm comfortable with Linux, and I set up that environment so that I can do, Python. If I want to do automation, I'll put Ansible in there. I put a DNS server on for this lab just to show, hey, it can run the service like DNS. So you can have actual DNS services running in your network and have your host respond accordingly. NTP, switches, logs, useless without NTP. So now we can get some time server done. I think the most interesting one up here is Squid, though. A lot of people ask about how can I get access to UI. So FMC has a GUI, SD-WAN has a GUI. If you set up a proxy on that Ubuntu node, you can point your web browser at it and then access the GUI through the proxy. It's super easy to set up. So that's kind of the start. The way I kick off all of my nodes is there's a configuration option for all the nodes where you can kind of put some rough configs in to get this node jump started. This is the Ubuntu node. I set up IP addresses. I set up the interfaces I want to use. So there's 3 interfaces here. One is to my home network, one to out-of-band management, and then one that points all the traffic for my other IP addresses into the CML lab that I'm building. And so the external connectivity options that you have available. So I talked about bridge mode, but the other one we're going to use today is NAT. And a lot of people ask, how do I build internet access out of my network? If I want to simulate what a router would do to go to the internet, how do I do that? If you use the NAT external connector type, it'll pull an IP address down, and then you can set up your router to do NAT translation. And I mean, that's how the internet works for most of us. It just pulls an IP down, and you do NAT because we don't have 1,000 public IP addresses to get out to the internet. So I kind of simulate it doing that, do the translation of all the addresses out through that router. The bridge mode is really powerful, though. So it gives us a way to bring in SSH from external hosts to the CML hosts. We can do tools. So we can bring in things like Nexus Dashboard, Catalyst Center. If you have an external SD-WAN manager, you can pull it in and run the node types just from that external manager. We can get internet access as well. So it's a very powerful way to get a variety of things in there. If you want to play with other software packages, if you have some stuff like some logging servers outside, you can direct all the nodes out through that bridge and have them send their logs. One very important thing I like to tell people about is make sure you add your interfaces before starting the node. I find this, people think this is frustrating, and it definitely is, because you start up the node, you can add 4 interfaces, usually starts with a couple interfaces right out of the gate. If you don't add your interfaces, if you don't add enough, when you start the node up, it's going to lock that out. So what I tend to do is, as you connect nodes up before you start everything up, it'll automatically add extra interfaces. But if you think you're going to want more, maybe you throw a router in there, maybe you throw a switch, and you're like, hey, I might want to throw a couple extra nodes in there. just hit add 4 interfaces, or maybe tap it a couple times. There are limits to how many interfaces the nodes will support, but it's a pretty significant number. So let's continue building out our network. So I mentioned we're gonna have an out-of-band management network. I always put this in there because I want out-of-band management. I do not want to do any kind of automation. I don't want to do any kind of configuration in the data plane. And that's mainly because if I break something with my automation, I want to be able to go back to the out-of-band management network and fix the problem. I have the ENS4 interface up, so that's connecting to a leaf node. It's a Iowa L2 switch. It's just going to provide access services, so I'm just going to do a switch port there. It's going to be the link that provides your DNS and NTP to the network. And then we have, again, that management port for out-of-band management. Again, scripts, Ansible, whatever you want to do with it. Just a safe way to do those configurations. So with the Iowa L2 node, with my switches and routers, I go a little bit heavier on the configuration. I always start with the host name. I don't want it to come up saying insert host name here. So I set up a host name of CML demo leaf 1. I configure a management verf. I set up the address family IPv4. I pick a high interface. I'll usually connect my out-of-band management to a really deep interface in the list. So in this case, I used 1.3 that gave me about 8 interfaces that I could work with then. I have DNS set up, so I set up my DNS name of cml.lab, and I generate a crypto key so I can actually do SSH. Get my username and password set up. So I set up line VTY, set up my login, set up SSH access, and then my username, privilege 15, so I'm getting in right away with having to do enable. And then this is optional. I only did this because we're going to have the switch on the network. Set it up in VLAN 100, and I applied description and access mode config. So how can we expand this out? And I've already given this away, but you could do a single router on a switch. If you're kind of getting started with networking, you want to learn like the router on a stick. Set up the NAT connector, bring it into a router, trunk your links down to the switch, and then provide access to the 3 hosts below. Or you could expand it out. Maybe we add a firewall. Put the 2 switches in there, do distribution, run HSRP. We have 2 leafs now. Maybe we do port channeling. We provide access to these Ubuntu services hosts, can provide services to these 2 VLAN hosts here. But that's not rock and roll enough. Let's put a VXLAN fabric in there. So we're going to have this VXLAN fabric in there. It's 6 nodes. We're going to have the edge router and provide internet. It's going to give us experience with a couple different things. We're going to get experience with VXLAN or BGP, underlay protocols, overlay protocols. And so we put this data center VXLAN fabric with internet access into our lab. It's kind of blasé. Nobody would know that's a VXLAN fabric. That could be anything. So let's improve the look of the lab. Let's annotate and document it. I tell everybody when they're working with their labs, make sure you document. It's just good practice. It gets us into that procedure of building out documentation, writing up how things look. You could come in here and you can clearly see where things are connected. We can see the VLANs. We can see the VNI definitions for the VXLAN fabric. We've got standard text definitions to indicate where our NAT is being done and where the host is at. We've got the smart annotation indicating where the VXLAN fabric is, this nice yellow triangle. And then we've got our spines. So we can see a clear definition of where our leaves are, where the fabrics are, where the spines are. And then we can look at our hosts and see what VNI the VLAN attaches to. This is pretty clear. Anybody could look at this, I think, and get an idea of what is being done on the network. So it's my opinion that this is much better. This looks really good. We still have plenty of room to add resources. We can expand this out. We're at less than or a little over 1% utilization for CPU, 30% of our memory. We've allocated 10. So like I said, super lightweight nodes with those IOL images. So let's extend out this network. I have a data center network now. I could put an enterprise core network in. I could put a service provider network in there. Maybe I put 2 VXLAN fabrics in and run segment routing in the middle. Maybe I do what I've done here, and I have just OSPF running and BGP, and I've got different buildings I want to connect to on my campus. Put firewalls in between it to do packet inspection, maybe an IPsec tunnel over the top. So we take that, we add this enterprise core to the network. We've documented our OSPF area. We've got firewalls. We have VLANs in other buildings. We have a pretty extensive lab here now. Does everybody think that's a pretty good sized lab? you think that would give you good hands-on with networking? Yeah. So all of our licenses are being used. We've deployed all 20 of our licenses. I'm running 27 nodes in that lab. The included third-party nodes, which I've made a note about, they don't consume resources. So Alpine, T-Rex, the Ubuntu host, WAN emulator, they don't burn node types. You can put a lot of them. That is not true of free tier. But for the personal plus, and enterprise, they will not cost you a node license. We've oversubscribed the system. I have 28 gig of RAM allocated for all of those nodes. I'm not even close. The biggest memory users are the firewalls, and the CPU utilization spikes occasionally because of IPsec tunnels running in the design. So can I prove this network is doing anything? I showed you this network. I've told you that I did a VXLAN fabric. Can I actually prove anything? So let's operate the network. Let's use some of the tools that we have in CML to actually operate the network. So we're gonna log in. I used my laptop, which is in my bag, and I SSH'd from that laptop to the Ubuntu services node. You can see in green, netadmin at Ubuntu services. So I'm on the Ubuntu node in CML. From there, I SSH'd to VLAN 50. Because this is a VXLAN fabric, I'm going from VLAN 100 to 50. I have to do a layer 3 VNI to get to that host. So I get to the host, I'm logged in, I do an NS lookup. A time server is set up, DNS is running, so I'm getting a DNS reply from the Ubuntu services host, and we can see that in the server address above. But I can also get out to the internet. I said, let's do a wget to ciscolive.com. Well, now we know DNS is functioning. It's getting things other than what I set up in DNS, and it downloaded some stuff from the internet. And if we look at the packet capture, we take the packet capture that you can do in CML, you can save it off and you can pull it into Wireshark. So you can take it and you can expand it out and start digging into detail all the logs and PCAPs that are occurring in your network. And so if we look, we see at the top in pink, we can see the leaf connection. We can see that VTEP to VTEP communication. We look down, we expand out the VXLAN. We can see the VNI that it used for encapsulation. And then we can see the actual encapsulated packet. We can see all the way at the bottom, we did a UDP to 53 DNS. We can see that we queried for time.cml.lab, and we got the 2 responses back. So not only did you get the visual on the server, on that Alpine host of what was going on, you can look at the packet capture and understand what DNS is doing. That's a really good experience. Like if you've never worked with DNS, if you've never played around with PCAPs, you want to get more experience with it, putting services into the network and actually seeing how they react, what would happen, what's the communication like to the DNS server, what's the communication like coming back, you can see that. And you get a lot of detail here. I mentioned earlier you can change link conditions. So I'm gonna change my NAT connector. I'm gonna set 10% loss. I just set the jitter to 2 milliseconds and 1 millisecond of latency. That's not a lot, but the loss is significant enough. So if we adjust the link condition, what would the before and after look like? So I did MTR. It's a great trace route tool. Shows you all the loss. Nothing's wrong. I'm going out from my host, getting all the way out, no problems. All the way out to ciscolive.com. 41 packets without an issue. As soon as I turned on that loss, we can see right where the NAT translation is being done, I'm taking 14% loss. If I had let that run out for 100 packets, it probably would have come out to about 10%. But that was instantaneous. As soon as I hit 10% loss, I was losing traffic. So again, like if you put these link conditions in there, if you want to see how it would change the behavior of your network so you could adjust policy, it's going to happen instantaneously and you will start to see changes in how your network's running. We can add additional services and packages. Because I've added internet access to these nodes, I could pull down things like HTTP. There's a great tool called Late HTTPD that's really great. It's really lightweight, spins up a small HTTP server. You could run that if you want to play with HTTP, see what the protocol looks like running through your network. You set up a web server. I set up a web server on there, and I put this small little Welcome to Cisco Live page out there. I asked the chat bot to do it because I haven't done HTML since GeoCities, which ain't shit. Yeah, I was waiting to see how many people would pick up on that. Right. Yeah, so it's been a long time since I really spent time with HTML. So I asked the chatbot, can you please make me a nice little web page so I can display my presenter information, remind people to do their session surveys, and tell them a little bit about my session. What about that hardware I told you about? Now, I don't have a super cool demo to show you what the hardware was doing, but I set the Ubuntu host up externally of the fabric. It has to traverse all the way through the network to actually do anything. That upper right-hand corner, maybe left for you, there was a small little external connector that sent it back out through this little switch here to the Ubuntu host. So the traffic came back into CML, passed through OSPF, passed through a couple firewalls, which we'll see in a second, and I did a DNS request. So I asked it, can I get to CiscoLive.com? Told me where it was getting its answer from. We can see the response back from the server. I brought up Firefox, said, can you show me the web page? So now I'm getting a desktop, got some equipment in there. I did a Ubuntu host because that's what I had. This could be a router. This could be another switch. This could be a really big network hiding behind the scenes. One of my coworkers set up a VXLAN fabric where 2 of the fabrics were in CML, 2 of them are physical hardware devices. The external connector brings it back in. So the firewalls that I put in there, I mentioned that I was sending traffic out through the Ubuntu host. I was trying to do a speed test on it, and I couldn't figure out why speed test wasn't working because I wanted to demonstrate the speed that you get through CML. It's not super blazing fast, but it's decent enough. So if you look, you can see good old ASDM. I got to ASDM through the proxy. Good old Java actually worked. You can see I got a bunch of little yellow prompts. Something is being dropped. We're losing traffic somewhere. And it was because I didn't have access to the speed test server. So I can go back and I can manage policy now. I can say, well, I would like to get to the speed test server. I can update to allow HTTP through. But you're getting the same physical response from the server, from the firewall, that you would with real hardware. So if packets are getting dropped, if you're losing things, the firewall is going to respond accordingly. It's not going to take some magic virtual path. It's got to go through the software. So let me leave you with a final thought. And that thought is that the only limit to what you can build is your imagination. I know that probably sounds a little corny, but I'm going to tell you about this lab in a second. The other being resources. I built this lab for a customer demo. I use CML for everything. I demo everything out of CML because of how powerful I find it to be. So for this lab, I had a customer ask me, I want to do ASA to FTD migration. I want to see what that looks like. I want to see how FMC works. I want to see what the process looks like, what the GUI looks like. But then they asked us this completely crazy thing that I never thought we would ever do in CML, and they said, can we do vulnerability scanning? Can we put a Nessus scanner in there and see what the process would look like through a virtual network? Anybody think that that would work well? Hand, okay. I didn't think it was going to work great. I thought it would maybe give us a little bit of data. It actually gave us a ton of data. And so we set the Nessus scanner up in there. We did our vulnerability scans. We did the migration. And so we were able to simulate with software without even having hardware at our disposal. Everything going through CML, doing that migration. The Windows server that hosts the migration tool was sitting outside CML and VMware. We just piped it into the physical switch here, or virtual switch, shifted the links over, had to clear ARP on this node, and then everything started working. Just like you would do in physical devices. You're going to migrate your software, you're going to move things over, move some cables around, but we tested it in CML. We got good hands-on, we got good comfort with the migration tool before we actually did it in our production network. So that if something were to go wrong, we're not scrambling to fix our production network, we're resetting CML and starting over and trying again. So, I've got some additional resources for you. Again, I provided the CML lab documentation, diagrams for that lab. They are fully built out. You can see where all the addressing is. You can see where, how I've set things up, what the nodes are, where the IPsec tunnels are running. If you have not looked at it or you've not heard about it, you can get access to the CML free tier. I have provided the CML resource calculator. Now, I mentioned earlier about the CPU. it's going to take all those virtual CPUs, and it's going to say, oh, you need 320 CPUs. Don't read too much into that. Focus on the memory. The memory is really the most important. If you can provide a lot of CPU, do it, but really focus on the memory aspect for the labs you build. CML documentation, this will walk you through all the details in the lab, logins, what you can do with them, what's been tested with the nodes. And then I provided the guide that I used to configure VXLAN on the IOXXE devices. So this will walk you through if you want to test out some of the show commands, get some experience with how to look at BGP and how to do verification that the network is working. The guide is there. And then finally, a cloud init, super powerful. If you want to spin up your Ubuntu host to do a million different things, that guide will tell you all the little hooks and options that are available in the configuration tool to set that node up. They're all valid for that node in CML. Any questions before I close this out?
What version does it take to get clustering?
I think it started working after 2.6, or it might have been before that. But it's enterprise only. Enterprise and education.
I might have missed it because I got here late, but the install for this on like the small hardware that you have, is it bare metal or application? Or?
It's a bare metal.
Okay.
Any other questions?
Does the VXLAN have a licensing restriction?
Nope. So the IOL node, there's no licensing or anything. The other node types, it's more of a bandwidth limitation. On all of the nodes, it won't push a lot of network traffic. Any specific questions around the band? Like, is it? So CML has a bandwidth limit of, I think it's a gig through the entire network, through the actual backplane that's running in the virtual network. I was getting, with my speed test that I did get to work from one of those Alpine nodes, it was telling me about 95 megabits a second. So it was actually getting out pretty quickly. You're not going to do software transfers. It's not great for things like that, but moving packets around, like it'll move things around pretty smoothly. Any other questions?
Are there any more in-depth resources on how to utilize T-Rex?
I can get you some guides on using T-Rex, yes.
Is there any plans to integrate with like the learning at Cisco to have pre-configured labs with like lessons that are integrated?
So I think there's some talk about that. I would go to the Learning at Cisco booth. There's a CML group over there. They can probably give you a little bit more feedback on that. Any other questions? Good? All right. Well, please make sure you fill out your session evaluations. I really want to come back to Cisco Live. I got to do it last year, and I would be super stoked to come back and do it next year and talk to you more about CML and other use cases. There's lots of learning to be done. If you do your evaluations, you could win a pass to Cisco Live next year. You can continue your education. Lots of great sessions here. There's a lot of stuff. I think Hank Preston's in here after me talking about programmability. 100% applicable to what you can do with CML. The things he talks about, you should be able to do in CML. Any of the other talks around data center, enterprise, you can look at those lessons and then take them back and do it with CML. If you have any questions, and I mean this seriously, please reach out. WebEx, the room, email. I will answer any questions you have about CML. I think it's super valuable. I think it's super powerful for you as network engineers to get more experience with things and understand how you can leverage it. So if you have any questions or concerns or things you want to know about, feel free to reach out to me. Thank you for coming to my talk, and I hope you guys have a great rest of the week.